Hello, and welcome to this calculus lesson. Concept I want to talk about in kind of a story format here is something called the mean value theorem. Mean not meaning angry or rude like a math teacher, but mean, we are not angry and rude, but some people think we are. Mean meaning average. And the idea of the concept mathematically is that if you have an interval over which your function is continuous. Now, this function I've drawn here is a distance function or a position function. Happens to be distance because I'm always moving in the positive direction versus time. So that function is continuous, and that function is in green. I've already drawn in some of the other things, so you don't have to take the time to watch me try to scribble it out. But this green path here is my trip to work. This distance is the distance from my home. I start out, I zip up the hill kind of quick, I stop at the stop sign, I go a little bit, I have to slow down a little, and then I take a turn, and then I'm on the highway, and then I get off the highway, and I have to wait a bit at a light, and then I go to another stop sign, I wait a bit at a light, and then I get to Mino's roast beef or something. Oh, wait a minute, no, that's up here. This is, traveling along, there's a little bit of traffic, I get to Mino's roast beef, I wait at that light, and then I'm zipping down Euclid Ave. And now notice my speed is increasing because the slope of this position graph is getting higher. And right here, I get pulled over by a friendly police officer for going over the speed limit. The speed limit there is 25. Maybe it's 30. Let's pretend it's 25. And the officer pulls me over, and I note it's been 30 minutes since I left my home, and I've gone 10 miles. So I've gone 10 miles in 30 minutes. That's 10 miles in half an hour, 0.5 hours. That is an average speed, the slope of this red line, of 20 miles per hour. So the officer pulls me over and says, "Good morning, ma'am. Do you know why I pulled you over?" And I say, "Good morning, officer. I'm not sure. Could you tell me?" And he says, "You were speeding." And I say, I don't think that's possible. You see, I left my home 30 minutes ago or half an hour, and I've only traveled 10 miles. So I've only been going 20 miles per hour, and the speed limit is 25 miles per hour. So I was not speeding at the moment you pulled me over. Now, some of you are going, hey, that's a great argument. And some of you are going, wait a minute. Right, because that 20 miles per hour takes into account all the stops I had. I had a stop sign here, I get off the highway, on the highway, I had a red light here, I had another red light here. When you get pulled over, you don't get pulled over for your average speed. The officer has no idea what time you started and how far you've gone. You get pulled over for your instantaneous speed. So what the officer is concerned about is the slope of the tangent line right here being more than 25. So that's the difference between an average speed or an average rate of change of a function and an instantaneous speed, or in this case, it's actually velocity, but we're going in one direction, so we can ignore the fact that it has direction. Instantaneous velocity versus an average velocity. This 20 is the average velocity. You get pulled over for your instantaneous velocity, which is the slope of the tangent line at the point at which the radar saw you. So average and instantaneous are different, but here's what the mean value theorem says. It says that if you have a function like this green one that's continuous, no breaks, jumps, you should know what continuous is now. It's just that you can draw it without taking your marker off the paper or your pencil off the paper. There, for any interval on the function, in this case the interval is from 0 minutes to 30 minutes, the average rate of change, or half an hour I've been using hours. The average rate of change, which is the slope of this red line that connects the 2 points. So I have an x1 is 30, a y1 is 10, an x2, or it could be the other way around, the 2's and the 1's, but the point is I can do y1 minus y2, just the slope of the line, over x1 minus x2, and I get 20. If I do that, what the mean value theorem guarantees is that there is some point on this green function at which the slope of the tangent line at that point is exactly 20, or is parallel to this point that's drawn between the two endpoints. So what you do is you find the average rate of change. You find the 20, and then you say, oh, if I had no, you don't have an equation for this function, I want to find out where does 20 equal f prime of x, and you find the derivative function, and you're going to solve that equation. Now, the derivative function for this function I've drawn will be a little complicated because it's a squiggly line. You'd have to fit a curve to that first. But basically, you find the average rate of change. Use the slope between the two endpoints. And you may not be given the y's. You may just be given the function and the x's and have to find the y's. And then you find the function for derivative and find out where is that average rate of change. So you solve this equation. This will be an equation with x's in it. It might be 2x minus 3. Now, that's a little silly. But it might be a line. It might be a quadratic, in which case you have to use factoring or the quadratic formula. But you find some function in x and find out where you find the x value that gives you the same, where the derivative is the same as what you got for the average rate of change. So that is an overview of the mean value theorem. Okay, thank you for joining me for this lesson in the mean value theorem.